Hello and welcome back to Apt for You. In this particular video, we will be discussing about a new problem from linked list, a very important problem, which basically says that we have to merge two sorted linked lists into a single linked list, right? So given on the screen, there are two linked lists. So one linked list has nodes 5, 10, 15, 40. Linked list 2 has nodes 2, 3, 20, right? And we need to merge these linked lists into a single linked list, and that too should be sorted. So basically we are expecting the output linked list to be 2, 3, 5, 10, 15, 20 and 40, right? So we basically have to merge this into a single linked list, right? 2, 3, 5, 10, 15, 20 and 40 or by null. So this is our expected linked list, which will be sorted, which will be in sorted order and will be combined into a single linked list. How can we solve this particular problem? There are different approaches to solve this particular problem. We shall start with the less efficient to the most efficient approach. So in this particular video, we will basically see one of the simplest way of solving this particular problem. How can that be solved? So first of all, we will try to develop an intuition how one can manually solve this particular problem, right? That is, if we are provided with two linked lists and I manually have to sort them, I manually have to merge them into a single linked list, what will be my approach? So basically, if we pay attention to the problem, so we have this linked list, right? Linked list 1, linked list 2, and we are provided with a pointer A, which is pointing to the head node of this linked list, and a pointer B, which is pointing to the head node of this linked list, right? Now if I am going to solve this particular problem manually, what will be my approach? First of all, I'll compare the first element of this linked list and the first element of this linked list, right? What will I do? I'll see which is the smallest one and I'll pick the smallest one, because I want the linked list to be sorted in ascending order, suppose, because this linked list is already in ascending order, right? These two, and I want to have a resultant linked list, that too will be in ascending order. So first of all, I'll compare the first elements of both the linked list and I'll pick the smallest one. So basically I have picked up 2, right? And once I pick up 2, what will I do? Now it's time to pick up the second node. So for the second node, what will happen? I will have this linked list and I'll consider this linked list, right? Why have I deleted 2 from here? Because I have already picked up 2. Now I have a choice to be made from the remaining linked lists, right? Which will be my second element, that will follow 2, right? So again you see, we are doing the same step. What is the same step? That is, we are comparing the nodes to which A and B is pointing, and again we are going to pick up the smallest node. So what will be picked up again? Now in this case we will pick up 3. So basically we will get 2 followed by 3, right? And again, since 3 is already picked, so next time what we will see? We will see that we will be having this particular case, right? Wherein if you find, you can observe, let me just use this pen. Yeah. So 2 and 3 are already used, right? Because they were the smallest so far. 2 and 3. Now we are left with this linked list. So A is pointing here and B has now proceeded to this particular node. Again we are going to compare 5 and 20. The smaller one is 5, right? So 5 will be picked again. So 2, 3, 5. 5 is already picked, so 5 no longer exists here. Now we are left with this linked list. So A is pointing here and B is pointing here. So what are we doing again? Now again we are comparing the elements at point A and at point B, and we are going to pick up the smallest node. So smallest node is 10. We are going to pick up 10 again, right? So again in the next time we will see that 10 will no longer be considered. We will have a linked list with 15, 40 and 20, for example, here in this particular case. So again we saw that 2, 3, 5, 10 were already considered. Now we have a node A, pointer A pointing to this node, pointer B pointing to this node. Again we are going to compare and pick up the smallest one. So the smallest one is 15. 15 is picked, and again we see we are left with this node and this node. So A is going to point here now, right? B is going to point here now. Again we are going to do the same thing. What is the process? Again we are going to compare this node and going to pick up the smallest one. So again we will have 2, 3, 5, 10, 15 and the smallest one is again 20, right? Now what will happen next? Next we will see we are left with only 40 and null, right? So A is pointing to 40, B is pointing to null. What will we return? Now we are not going to compare them because we have only one element and we have null other side. So basically we are going to return A, right? Which means that, please note that whenever if B is equal to null, whenever B pointer was pointing to null, we have returned this A pointer, right? There might be other case where A is null, where A is null, and if A is null, we are going to return B, right? So this is also one of the possible cases where if B is null, we are going to return A, and suppose A is null, suppose this is null, and we have some element here 50. In that particular case, A is pointing to null and B is pointing to 50. So basically, if A is null, we are going to return B. Why am I doing this? Basically, if you observe, so far whatever we are doing, at every iteration, we are basically repeating the same process, right? At every iteration, we are doing the same thing of selecting the smallest from the two nodes, picking the node, and then doing the same process for the nodes following it, right? That is what we are doing. Suppose like here we picked up 5, we compared 5 and 20, we picked up 5 and again repeated the same process by considering linked list 10, 15, 40 and 20. So basically we have developed an idea about recursion. So we are getting an idea that okay, recursion will be playing a good role in this particular problem. How can we solve this particular problem using recursion? So if you basically look into the code of recursion, a very good code is written here, sort of a pseudo code. First of all, we will declare a function, declare a node pointer result which will point to null, right? So let us declare our node pointer result which is pointing to null. The next step will be, just now we discussed the terminating condition, right? In terminating condition, two things are possible. When A is null, then we will return B. When B is null, return A. Just the previous slide we discussed this particular thing, right? What is next? Next is, now what we are doing, every time we have a pointer A pointing to the first node of this linked list, pointer B pointing to the first node of this linked list. We are comparing the two elements and we are going to pick up the smallest one. So if A data is less than equal to B data, suppose if A data is less than equal to B data, which means this is the smallest one, so basically the result pointer should point to the smallest node. Getting the point? Suppose the smallest it should point to the smallest node, else it will point to the if A is not small, indicates B is small, right? So it will point to B. Like in this particular case, A's data is 5, B's data is 2. So result 2 should basically point to the node 2, right? And now what will be 2's next? Now 2's next, basically we have to decide. How will we decide? Again, we have to take the help of this particular function, merge sorted list, isn't it? The function for which we are writing the code. So basically we are going to repeat the process. Now since we have already found 2, now in order to find the node which will follow 2, you have to do a recursive call on this entire linked list and this linked list. Now remember, in this linked list we are not considering 2. So basically I am calling the merge sorted list on B's next, because B is right now pointing to this node, so B's next is this. So basically I am considering this entire linked list and A, this linked list, complete linked list, right? And if in the next time, suppose we are comparing 5 and 3, next time we are comparing 5 and 3 because next time B comes here. So this time you see again B is small, so again what will happen? Result pointer will point to this particular node 3, right? And 3's next will be, again that will be decided by calling the recursive, by doing a recursive call on the linked list with node 20, because I will not consider this again. B next, comma A will still be the complete linked list, right? So this way we will find that using recursion this entire problem can be solved, right? And finally, what is it going to return? It is going to return the result, that is the pointer. For example, let us decode the steps, right? How is it actually working? So let me just use this particular ink. So first of all, my A is here and B is here, right? So as per this particular algorithm, result will be equal to B because B is small. So basically I will first of all, you remember, first call I am getting a result pointer null and I am pointing it to B. B is nothing but 2, and 2's next will be depending upon what? Merge sorted list B next comma A. So this will again be dependent upon the value returned by the recursive call of this, right? So basically I am passing this linked list and this linked list. Remember, this is a recursive call here. So what will be selected again? A's data is 5, B's data is 3. So basically 3 will be selected, right? And since it was a new recursive call, so again this result pointer will point to null. This is separate. Remember, this result and this result will be separate, right? So because this is a recursive call, this is already stored in stack. Now we have 3 being created, right? Result is pointing to 3, okay? And 3's next will basically again be dependent upon a recursive call. So recursive call on this entire linked list. So B is now pointing to this and A is still here. So A's data and B's data, what is small? You find out that, let me just use this. I'm sorry. Okay. Yeah. So right now we have 2 and 3, and this is in stack. Now 3 is next. Again for 3 is next, we are passing this linked list with A is pointing to 5 and B pointing to 20. So again A and B will be compared. The smallest one is A. So what will happen? A result pointer will be created and it will point to 5, right? And 5 is next. How to find 5 next? 5 next will basically be a recursive call, again doing the same thing, wherein we are passing this linked list from 10, 15, 40 and this remains 20. Again A's data and B's data is compared and the smaller one is picked. So result pointer will again point to 10, right? Result pointer will point to 10, and again that next will be depending upon what? This linked list and this linked list, right? So I hope you are getting the point. Assuming that our linked list has ended here only. Suppose this is not, this no longer exists, right? Suppose this no longer exists. I'm really sorry. Let's not do that. Let's do one thing. Alright, so right now what we have is basically result. We have result 10, and 10's next again will depend upon what? 10's next will depend upon A is pointing to this, B is pointing to this. So again we are doing a recursive call where we are passing this linked list and this linked list. So again, which is the smallest one? The smallest one is basically 15. So again basically result will point to 15. So remember, I am just continuing this here. 15, and what will be 15's next? That will again be a recursive call. That will be decided after doing a recursive call on this linked list with only 40 and this only 20. So again, which is the smallest one? This is going to be going on the stack, and again we have result pointing to 20, right? Result will point to 20 because this is the smallest one, and finally B will point to null. And we remember we are reaching to the terminating condition, that is if B is equal to null we will return A. So what will be returned basically? So result 20. And what will be next? Next will be nothing but what will be returned in this case. When I am doing a recursive call on this particular linked list where A is pointing to 40 and B is pointing to null. So this particular basically is going to return A. So 40 is going to be returned. What does it mean? It means we have a linked list result 20 followed by 40. Now we are done with this particular job, right? And finally you see, after every recursive call is made, we are returning the result pointer. So this recursive call is successful, so I returned 40. This recursive call was successful, so what will it return? Result pointer, and result pointer is pointing to 20. So basically this will be like 15, 20, 40, the status of the linked list, right? And again result pointer is pointing to 15. If this is returned, which means that here I will be getting 15, 20, 40, right? So 10, 15, 20, 40. Again this result pointer is going to be returned here, so this will create a list 5, 10, 15, 20 followed by 40, right? Again result pointer is pointing to this particular node here. So if this is returned, it means 3 will be having next as this node, right? 3 will be having next as this, right? And similarly if this returns result again, so which means we will have 2 followed by 3 followed by 5, 10, 15, 20, 40. This is how the entire recursive step is proceeded, and finally you see we have prepared the sorted linked list. I hope you are getting the point, and I hope you have developed the intuition about how things are actually working. So without further delay, let us quickly jump into the coding section, right? So I have picked up the problem from Geek for Geeks and I will try to code there. So this is the particular problem, merging two sorted linked list, and without any delay let us quickly jump into the problem. So you see basically we have received the pointer to the head nodes of two linked list, right? So basically I am going to use the same variables that we used throughout the explanation. So struct node star A, star A is equal to head 1, right? And again I am declaring struct node star B is equal to head 2, right? So my A and B are pointing to head node 1 and head node 2, right? What was next? Next I will be writing the I will be creating another node, right? Result. I hope you remember why you are using the result pointer. So struct node result, right? Struct node result is equal to null, right? I hope you understand the importance of using this pointer. This will keep track of the nodes that we are selecting, right? And finally I'll be writing the terminating condition. So terminating condition was if A is equal to null, basically we are returning what? The list, the pointer to the second list B, right? And if B is equal to null, what are we going to return? We are going to return the pointer to the first list, return A, right? And finally what will we do? If the linked lists are fine, both linked lists have some elements, we are going to compare A of data is less than equal to B of data, right? If this is true, which means the element in the list A, the element in the first list where A is pointing to is small, right? So basically our result pointer should point to A, and again results next means the node following will it be decided by a recursive call, right? And what will be the recursive call? The function basically sorted merge. So I'll write sorted merge, and I'll basically pass the pointers to the two lists. So first of all, considering the list A, so since I have already picked one of the element of A, so basically this will be my result pointer pass. I'll be passing A next, right? Because I have already considered one element of this linked list as it was a smaller, and I'll pass pointer B, right? So this was done. What will be the else part? Else part will again be quite similar. Else part will occur when basically the element in the list B is smaller. So basically that time our result pointer will point to B, and result next again will be decided by a recursive call. And in this particular case we will just pass A because we have not picked any element from A, but yes, we have picked one element from B in this case, right? So B next, right? So this recursive call will continue, and we know that finally after the successful functions I have already computed, then after every recursion we are going to return the result pointer, right? Return result, because this pointer is going to store the linked list, right? What linked list we have obtained throughout. And I hope, yeah, that should work. So let us just compile this particular code. Okay, you see 5, 10, 15, 40 and 2, 3, 20. We have basically, you have two linked lists, this one and this one, and we have successfully sorted them in ascending order into a single linked list. So if I submit it, okay, let's see whether it's submitted. Yeah, execution time is 0.37. This is successful. Talking about the time complexity, so this basically has a time complexity of order n, right? I hope you remember why order of n. Basically because we are traversing the, sorry, not order of n, basically it depends upon the length of the two lists, right? So order of m plus n. This is the time complexity. I hope you remember why it is order of m plus n, because this is the length of the first linked list, this is the length of second linked list, and since we are traversing both the linked lists, isn't it? So order of m plus n. And talking about the space complexity, I hope you got the answer by now. Since we are going to use recursion, since recursion is used, so obviously it is going to take a stack space, right? The stack will take space, and that space will basically depend upon the number of nodes that are present, right, in both the linked lists. So basically again that will also be order of m plus n only. So basically it is also linear, and time complexity is also linear. So I hope the video was quite helpful. Yeah, it went a bit longer, but yeah, that's fine. So that's all from my side. I hope this video was helpful and intuitive. So please put your doubts in the comment section if any, and just like, share and subscribe. Thank you.